Oh, hi. I'd like to spend a couple of moments talking about significant figures, telling us what kind of accuracy and precision we can report numbers. Let me put up a number and make it into a value by putting some units on here. We have some scales or balances here in the Department of Chemistry at OSU that can measure way out here to the 100,000th of a gram place. Zeros on the left are not significant. They're simply placeholders. You can go ahead and change this number into scientific notation. 1.070 times 10 to the negative. We're moving the decimal place to the right 2 times 10 to the negative second. I need to still include my units of grams there, and the zeros on the left have disappeared. We call them placeholders. They're not significant. Certainly the zero in here is measured. The balance that I used is reporting this to be a 0. The balance is also reporting this to be a 0. I am not free to just throw zeros on the end of this value. It's implying that I know these numbers to be 0. I might not. But in fact, the balance did weigh this one out to be a 0. So the number of significant figures in this value is 1, 2, 3, 4. Let me put a 4 and circle this here. You can do the same exercise here without this being in scientific notation. Just make sure you do not include zeros to the left. When we do operations such as multiplication and division, addition and subtraction, we can keep track of significant figures as well. Let's do multiplication and division first. I'm going to take two numbers, 2.34, and multiply them by 17.238. These might be centimeters for a measurement of an area. Might be something else. They might be time units or something. On my calculator, I'm going to get an answer, and my calculator is not helping me out with significant figures. I enter 2.34 and multiply it by 17.238, and my calculator returns the value of 40.336920. That's what my calculator is telling me. For multiplication and division, here we just did multiplication, we use what's called the weakest link. This value has 3 significant figures. This value has 5. When I'm all finished, I need to report my answer to the weakest, or the lowest number, being 3 in this case. We know this value to be 40.3, and we don't know the rest of it. When we do addition and subtraction, we don't use the weakest link. We use what's called the placeholder method. We add 2 numbers, perhaps, because we take 2 samples and add them together, and we make it look like 4th grade arithmetic. 1.72 grams is added to 21.11403 grams. If we were to use weakest link and say this value has 3 significant figures and this one has many, like 7, we would say, oh, we can report our answer to 3 significant figures. But we don't use weakest link. We use placeholder, and what's meant by that is, maybe draw a vertical line to help yourself out. We know both values to the hundredths place. Tenths, hundredths, albeit we know this one far more. We can't use those because these numbers, 4, 0, and 3, are being added to something we know not what. So when we're all finished, we are not to report the 4, the 0, and the 3. We can only go out to the hundredths place, tenths and hundredths. So we would report this value to be 22.83. And take a second to note, this value has 3 significant figures, 7, and our answer ends with 4. So you must use the placeholder method, and I would not have guessed that this would have had 4.